Alright everybody, we've got factoring here. We're going to do the quick factoring review for getting ready for rational expressions in the next chapter. So, at the top here you might want to pause the video and fill out this factoring chart that we learned in Algebra 2 about when do I do what. Always start with the GCF, and then what you do is based on whether there's 2 terms or 3 terms. We're not going to really see any 4 terms, but I put that back on the chart like we had in Algebra 2. So pause the video and write this down. Alright, underneath, welcome back, we have some examples. We'll start here with x squared plus 3x minus 10. Is there a greatest common factor that can divide out of all pieces? No, there's not. It has 3 terms, and the a is a 1. Remember, a is here in front of the x squared. So we could just unfoil this. We know that the only way to multiply and get x squared is to have x multiplied with x. So we can go ahead and fill that out. And then remember, if you're unfoiling, you would have to find what multiplies to be the c value, negative 10, that can add to be the b value, which is positive 3. The 2 numbers that can multiply to negative 10 that can add up to be positive 3 are a 5 and a negative 2. Remember, if the middle number is positive, the bigger number of your pair will be positive. So we have positive 5 and negative 2 in our 2 factors, and we've turned that into a multiplication problem. So we are done. Alright, 4x squared minus 9. Is there a greatest common factor? Nope. They don't both have x's. 9 and 4 only can divide by the number 1. So no greatest common factor that helps us. But we're right here on the side. It is 2 terms. Is it a squared minus b squared, meaning a perfect square, something multiplied by itself, minus another perfect square? And I would say yes, it is. So we're going to be able to use the factoring difference of squares pattern here, a plus b, a minus b. Because a 4 is a 2 and a 2, so 2 squared. An x squared is clearly an x squared. And a 9 is a 3 squared. And it does have subtract. So difference of squares pattern here, we can break up all the squares. This 2 squared breaks up into 2 and 2. The x squared breaks up into x and x. Keep the order the same. The 9 breaks up into 3 and 3. And since it needs to be negative, one of the 3's will be positive, the other 3 will be negative. So a difference of squares example. Okay, moving on. Third example. Is there a greatest common factor? Yes. All of the numbers can divide by 2. And all of the terms have an x. Just one x, because that's all the end has. So the largest we can take out of everything is a single x and the 2. So when we divide by 2x, we're left with x squared. Negative 4 divided by 2 is negative 2. X squared divided by x would be x. Plus 2x divided by 2x, that would be a 1. Whoops, that's way too far. Didn't need that over there. Okay, now I'm left with an a that's a 1, and I still have 1, 2, 3 terms. So I should try to unfoil this, because I could definitely split up that x squared into x and x if there are numbers that can multiply to positive 1 that can add to negative 2. Well, the only way to get a 1 is with 1 times 1. But remember also that negatives, 2 negatives multiplied together, make a positive 1 as well. So maybe it's negative 1 times negative 1 to make positive 1. But then negative 1 plus negative 1 would add up to be negative 2. So we want negative 1 and negative 1 when we unfoil. Okay, final example. Is there a greatest common factor? Nope. 8 does not divide by 3 like the other numbers do, and 3 only divides by 3 and 1. It's 3 numbers long. A is a 3, so we're going to need AC method. So remember, A and C are the number with the x squared and the number with no x's. So multiply those together, get -9. And then find ways to break down the -9 that can add up to be 8. So it might be 1 and 9, or it might be 3 times 3. Remember, if you're going to make a -9, one of your pair needs to be negative, not both. So it's going to be a 1 and a 9 that can make an 8. If I want the 8 to be positive, then the bigger number needs to be positive, and the negative goes on the smaller number. The middle number, sign, matches the sign of your bigger number. Okay, now remember, when you're not unfoiling, because A is not a 1, you don't go straight to the parentheses. You start by uncombining the like terms. So that 8x is going to turn into -1x plus 9x, and we're going to subtract 3, and we're going to bring down 3x squared as well. So bring down the first term, the last term, and split up the middle term. Now we have 4 pieces, and when we have 4 pieces, we split it into 2 pairs, and we look for the common factor of the smaller pairs. So 3x squared minus x only has an x in common. Remember, the GCF does not always include a number. So that would leave us 3 with one of the x's, minus 1. And remember the idea, when you're using AC method, what you have in these parentheses has to be the same as in these parentheses. So I need that 3x minus 1 here. So what number must I have divided out to turn 9x minus 3 into 3x minus 1? Oh, 9 divided by 3 would be 3, so I must have divided by 3. -3 divided by 3 would be -1. Yep, that works. And so to figure out my 2 factors, I pull together the GCFs and write them as one factor, x plus 3, since it was a positive number, and 1 copy of 3x minus 1 that they were both multiplied by. Okay, so now try the problems at the bottom of the page and turn them in when you're done.